Ever found yourself pondering just how our vibrant, life-filled Earth came into existence? Buckle up and let's embark on a wild journey back in time, all the way to Earth's baby years, some 4.5 billion years ago. Imagine a world that's a far cry from what we're with today. Picture Earth with oceans stretching as far as the eye could see, volcanoes erupting with fiery passion, and an atmosphere starkly devoid of oxygen, leaving the planet at the mercy of the sun's merciless ultraviolet rays. Fascinating, isn't it? But just how do we know all this? Well, they're stored in the rocks. Think of rocks as Earth's personal time capsules, safely preserving the thrilling tale of our planet's early years. Now let's dig deeper into some of the oldest rocks on Earth. These relics, formed during the mysterious Archean age between 4 billion and 2.5 billion years ago, are treasure troves of information, unveiling the geological processes that shaped our world. Here's a fun term to remember: Cratons. Picture these as ancient puzzle pieces that once formed parts of the continents. Cratons are resilient chunks of crust that have weathered the storm of geological changes for billions of years. Isn't that mind-blowing? Now let's turn the spotlight to the Singbum Craton, an intriguing part of the Daitari Greenstone Belt in eastern India. This chunk of Earth's crust, dating back to a staggering 3.5 billion years ago, offers us a captivating glimpse into our planet's past. This ancient area is a treasure trove of volcanic and sedimentary rocks, giving us a peek into Earth's dynamic history. Our journey into Earth's past is nothing short of jaw-dropping, revealing a world that's a far cry from the one we call home. As we unravel the mysteries hidden in these ancient rocks, we're not just hearing stories, but we're gaining a profound understanding of our planet's history and evolution. Our Earth in its early years was a wildly different, dynamically evolving planet. What an adventure! Step into the time machine of Earth's very own rocks. The key to our planet's prehistory lies within the ancient volcanic and sedimentary rocks nestled in cratons. Cratons are the Earth's age-old treasures, the hidden archives of geological knowledge. They are the time-worn sections of our continents, housing an exciting assortment of rocks like the mysterious greenstones and majestic granites, each whispering their own tales of antiquity. Now buckle up, and let's teleport to eastern India, right into the heart of the state of Odisha. Here lies the Singbum Craton, an ancient piece of the Earth's crust that's as old as time itself, tracing its roots back a staggering 3.5 billion years. It's like stumbling upon an age-old diary from the Archean age. When we peel back the layers of the Singbum Craton, what do we see? A treasure chest, filled to the brim with ancient volcanic and sedimentary rocks. These are the creme de la creme of what geologists call greenstone successions. Greenstones are like a jigsaw puzzle made up of various submarine volcanic rocks and a dash of sedimentary rocks. These rocks were born in the depths of ancient oceans, each piece shaped by volcanic fury and the relentless rhythm of sedimentation. But wait, there's more. The Singbum Craton isn't the only marvel of its kind. Cratons are sprinkled like cosmic breadcrumbs across the globe, from the southernmost tip of Africa to the wide-stretched coasts of Australia. They each hold mirror-like similarities, preserving the same types of rocks in almost identical conditions from the same ancient epochs. Acting as the Earth's library of early surface processes, every craton stands as an enduring monument to the colossal geological forces that gave shape to our planet. Even more thrilling, these age-old cratons, these slices of the primordial Earth, throw open the doors to unimaginable discoveries. They grant us an exclusive pass to journey into the bygone eras, helping us unravel Earth's evolutionary plotline, one rock at a time. By immersing ourselves in their study, we get to unravel the geological mysteries that chiseled our planet's face, and the myriad transformations it experienced over eons. So, join us on this riveting journey into the past, as we delve into these ancient pieces of Earth's crust. Get ready to dive deeper into the fascinating mysteries of our planet's early evolution. We're about to embark on a global journey, comparing the Singbum Craton in India with other cratons in South Africa and Australia. Picture this. We're journeying back in time around 3.5 billion years, when our planet was bubbling, boiling, and brimming with geological activity. The Singbum Craton, a piece of the Earth's crust tucked away in eastern India, is our time machine to this fiery period. Populated with a variety of volcanic and sedimentary rocks, known as greenstone successions, it's like a treasure trove of the primeval world. These greenstones are frozen moments in time, preserving the story of the geological processes that were at play billions of years ago. Now hold on to your hats, because we're about to expand our journey to encompass the world. We zoomed in on Cratons in South Africa and Australia, specifically the locations of Barberton, Nandweni, and Pilbara. We chose these sites because, like our starting point, they serve as a time capsule of the past, preserving the same types of rocks in the same condition from the same time period. And what we discovered was mind-blowing. Despite the miles that separate these locations and their current environmental differences, they share a common thread, a shared geological past. The groundbreaking revelation: volcanoes were the fireworks of the early Earth. Explosive eruptions, most of submarine, were a part of our planet's daily life, painting a picture of a world dramatically different from the one we know today. These eruptions, deep beneath the oceans, played a starring role in sculpting the landscapes we see today and the formation of our continents. So, buckle up folks, because this comparative study of Cratons not only gives us a clearer picture of Earth's early evolution but also underscores the importance of greenstone belts as the keepers of our planet's early secrets. These findings have blown the lid off our understanding of Earth's intense volcanic activity, shaping the world we live in today. Venturing into the early Earth processes isn't just an enthralling expedition into the bygone era. It's an imperative piece of the puzzle that helps unravel the intricate, mind-boggling 4.5-billion-year-old saga of our magnificent planet. By probing into the formation of rocks, aged billions of years, scientists are painting a vivid and comprehensive chronicle of Earth's evolution, from its fiery inception to the world we inhabit today. But the question is, how does one study events that took place over 3 billion years ago? Here's where uranium-led radiometric dating, commonly known as UPB dating, steps in. This awe-inspiring technique serves as a geological time machine. It empowers scientists with the ability to ascertain the age of a rock, or to be more precise, the moment a magma crystallized to form that rock. This groundbreaking technique aids in establishing crucial geological timelines and uncovering the processes at play during those ancient times. Ponder upon the age-old greenstone belts nestled in Cratons, these enduring fragments of continents that have withstood billions of years of relentless geological activity. By juxtaposing rock formations from diverse Cratons globally, like those in India, South Africa, and Australia, scientists are weaving together a holistic image of Earth's primitive geological processes. Now you might wonder, why should we fuss about events that occurred billions of years ago? Well, by decoding these processes, we can uncover more about the conditions that may have nurtured life during diverse geological epochs. These enlightening studies illuminate the conditions that enabled life to sprout and evolve on our planet, and potentially guide our quest for life on alien planets. They make us marvel at the ancient geological wonders that are all around us, from the majestic mountains to the deepest ocean trenches. They compel us to acknowledge that our Earth is a dynamic and evolving sphere, with a narrative that continues to unfold. By diving deep into Earth's geological past, we gain a profound understanding of our role in its ongoing epoch. As we unearth more about our planet's past, we also unravel the mysteries of our own beginnings and the future that lies ahead. The rocks beneath our feet, seemingly silent, are teeming with enthralling stories. All we need to do is lend an ear and let them speak. Join me now as we recap our thrilling expedition into Earth's early evolution. Can you believe our magnificent planet formed a staggering 4.5 billion years ago? It was a dynamic world ruled by oceans and marked by volcanic eruptions that sculpted the landscape. Here's a fun fact. Cratons, these ancient chunks of continents, acted like key players in this grand transformation. They offer us an extraordinary window into Earth's past. We've been comparing the Singbum Craton with others in South Africa and Australia, and guess what we found? Evidence of explosive-style volcanic eruptions from about 3.5 billion years ago. These remarkable eruptions, both under and above oceans, have etched their history in the form of greenstone successions. Now, let's not underestimate these geological studies. They are significant. They help us unravel the intricate tapestry of our planet's evolutionary history and the conditions that could have nurtured life during varying geological epochs. Yes, my friend, Earth's age-old geological marvels continue to unveil new insights into our planet's past. Every discovery is a reminder that our world's story is much richer and fascinating than we can imagine.